Yeah. Wait, Ravi. I'll start the class. Just wait. We'll wait for others to join. Hello, students. Good evening. Good evening to all of you. How are you all? So I have launched a poll to check the class status. So please give me your answer in the poll which I have launched, and let me check it. So just let me know if I'm visible and audible. Am I visible and audible? Okay. Okay, now let's start with the class. So today we are going to start a new chapter, which is the first chapter of this Enable Plus program of chemistry in class 11, right? So the name of the chapter is Periodic Table, or the full name of this lesson can be Classification of Elements and Periodicity in Properties. Okay, so this is the third chapter of your NCRT book, or from your NEET syllabus and JEE syllabus. Okay, so now let's go for this lesson. So here we have two classification, two division, right? So first half of the lesson talks about the classification of elements, and the second half talks about the periodicity in properties. Now for today, I'm going to take the first half, which is the classification of elements. So before moving on to the topic, I would like to ask one question. Why do we need to classify the elements? Do you have any idea? Why do we need to classify the elements? What is the need? Why it is necessary to classify the elements? Students, tell me, why do we need to classify the elements? So I have kitchen utensils and clothes wardrobe like this and bathroom utilities. So in all these three cases, we are keeping the corresponding materials in a corresponding place, right? Like I'm having all the t-shirts in one place in a wardrobe, and in case of kitchen utensils, I have the what to say the cups in one place and the spoons in another place. And in case of bathroom utility, we have brush in one rack and soap, everything in the other rack. So why we are classifying the things like this, and why do we need to classify the elements like this? You can talk, you can give your answer in the chat box. Okay, you don't have to stay silent like this. You can talk with me in the chat box. What is your answer for this question? Yeah, Jainvi Bhavnagar, tell me, why do we need to classify the elements? Okay, I'll give you the total known elements. Okay, so now at present we have 118 elements in the periodic table. Okay, and new elements are also getting synthesized continuously. Okay, so if we are keeping on discovering and synthesizing elements like this, so and if you are going to place those new elements in some other row or column in a periodic table, then how will you study them easily? Okay, so to make the study of the elements easy and more efficient, we are classifying the elements and putting them in a separate column or in a separate row. Okay, so to make the study of the chemistry of the elements easy and efficient, we are classifying the elements. Okay, so we do have many classifications. Many scientists like Lavoisier, Newland, and Mendeleev, and some others also came up with their own ideas, and they have given their own laws. And according to the law, they have classified the known elements. Okay, like for example, if I take Mendeleev, during Mendeleev period, only 63 elements were discovered. And he gave one Mendeleev periodic law, and according to that law, he have placed all the known elements in his periodic table. Okay, now at present we have 118 elements, and we are going to place all these 118 elements in the periodic table in accordance with modern periodic law. Okay, so the first topic that we are going to study in this lesson is modern periodic table. So the other scientist names and their laws which I have mentioned now, they were out of syllabus now. Those topics got deleted for the last 2 years. Okay, from last 2 years onwards, we don't have those topics in our JEE or NEET syllabus, so we will not study those people's classification and their laws. So the syllabus is starting from modern periodic table only. So we are going to concentrate from this part. Okay. So the learning objectives for modern periodic table are introduction and periods and groups in periodic table and the blocks in periodic table. So what is the introduction to modern periodic table? What is the origin of this modern periodic table? It is because of this scientist, and the scientist name is Henry Moseley. So he only discovered this modern periodic table. So how he discovered? He did some experiments. Okay, he did some experiment, and he observed the some regularities and characteristics of X-ray spectra of elements. So he took an instrument which is called as X-ray spectrometer, and he observed the regularity in the characteristics of that X-ray spectra of some elements. Like uh, for frequency versus atomic number, he observed some regularity. So that regularity was a straight line. Okay. So the root of nu is called as frequency. So the root of frequency versus atomic number gave a straight line. So like he got a straight line like this. Atomic number is denoted by the letter Z. Frequency is denoted by nu. So root of nu versus Z gave a straight line with positive slope. So now by observing this regularity in his graph, he gave a law which is called as modern periodic law. And the law says that the physical and chemical properties of the elements are the periodic functions of their atomic number. The physical and chemical properties of the elements are the periodic functions of their atomic number, which is very important law for your board exam. Board exam means for school exam as well as for NEET. Okay. If the atomic number increases, then they do have some periodic regularities. So the physical property and the chemical property of each element, they are the periodic functions of their atomic number is the modern periodic law. Okay. And this modern periodic table is also called as long form of the periodic table. And this is that table. Okay. Modern periodic table is also called as long form of the periodic table. We have four sections here. Okay, I will come to those four sections later. So before moving on to that, so let's discuss how many periods and groups are here in the periodic table. Okay, so totally how many periods? Periods are otherwise called as horizontal rows. How many horizontal rows we have here? How many horizontal rows we have? So starting from this hydrogen row, this is row number 1, 2, 3, 4, 5, 6 and 7. So there are 7 horizontal rows which are called as periods. And how many vertical column we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and here 13, 14, 15, 16, 17, 18. So here we have from 13 till 18. So totally we have 18 vertical columns which are called as groups. Okay, so there are 7 horizontal rows and 18 vertical columns. 7 periods, very good, very good. 7 periods and 18 groups in the periodic table. So what is that last two groups? Last two rows which we have here. So the last two rows are called as lanthanoids and actinoids. Okay, so those two rows are called as lanthanoids and actinoids. Okay, so any doubt from the long form of the periodic table for anyone? Is everything clear and okay? Yes. So this is called as modern periodic table, which is otherwise called as the long form of the periodic table. Any doubt, students? Shall I go for the next topic? So here we have 118 elements. All of you can able to see, right? We have 118 elements in the periodic table. Now, we are going to name some elements. Some elements means the elements which have atomic number greater than 100. So from which element it starts? It starts from 101, Mendelevium. Okay. So from 101 till 118, we do have some 18 elements, and those 18 elements are going to be named using some rules. Okay, so that is the second topic. Students, am I audible? Am I audible? Yeah. So now let's see the nomenclature of elements with atomic number greater than 100. Okay. So the new elements with very high atomic number, that is from atomic number greater than 100, are highly unstable in nature. Okay, they are not stable. So the synthesis of those elements requires a sophisticated, costly equipment and the sophisticated laboratory. Since they are very highly unstable in nature, we have to use some costly experiments to synthesis the elements which have atomic number greater than 100. Okay. So now we are going to give the names for those highly unstable elements. But before moving on to the naming, why do we need this type of nomenclature for those elements with high atomic number? What is the reason? The reason is, so let me take an example. I am going to take the element with atomic number 104. So this is a highly unstable element with a high atomic number. Okay. Americans named this element as rutherfordium and the Soviets named it as kurchatovium. Okay, so two different groups are naming a single element by giving two different names. Okay, so because of these two names given for one single element, the IUPAC means the International Union of Pure and Applied Chemistry. Okay, it is an institution kind of thing. So that IUPAC people, they recommended to use a systematic nomenclature until new elements discovery has been proved. Okay. So nowadays we are following the set of rules which has been provided by IUPAC, and according to that rule only we are naming the elements which are getting synthesized newly. Okay. So now with this story we will go for the rules. We'll go for the rules. So the element name should be written as the root for each digit in atomic number plus IUM. Now what is the root for each digit? So totally how many digits we have? We have digits from 0 to 9, right? The combination of these 10 numbers only giving us the other numbers. So these are the 10 digits. Then the name that we have to use for 0 is nil, for 1 it is un, bi, tri, quad, pent, hex, sept, oct and n. Okay, so these are the names which we have to use for naming the digit. And the abbreviation is nothing but the first letter. Abbreviation is the first letter of the name. And for nil it is N, for un it is U, for bi it is B. Okay, so it goes till E. So now this is the notation for IUPAC nomenclature of the elements. Okay, so this is the rule. This is the rule which you have to follow. Now using this rule, we will try to name the compound. So clear up to this? Any doubt in the rule? You are going to memorize the name of the 10 digits, and the abbreviation you don't have to memorize. It is the first letter of the name. Only the 10 names you are going to memorize. That's all. And the suffix will be IUM. The suffix that you have to use is IUM. That's all. Is it clear for all? Is it clear for all of you? Shall I go for the examples? Shall I go for the examples? Yes. Yeah. So now I'll take one element with atomic number 112. Okay. 112. So now what are the numbers I have? 1, 1 and 2. So what are the names we have to use for this 1 and 2? For 1, un, and for 2 it is by. Now connect all these three. Un, by, and the suffix should be ium. So the name of the element is un, by, ium. Okay. So two vowel cannot be written next to each other, right? In that case, you have to use only one I. So by, ium is the name, and the symbol is UUB. the first letter of each name. U, U, B is the symbol. Okay. So very easy. So I'll take one more element with atomic number 108. Can you guys give the name of this? What is the name of this element with atomic number 108? So for 1, what we have to use? Un. For 0, it is nil. For 8, it is oct. So what could be the name? Un, nil, octium. Very good. Very good. Very good. Un, nil, octium is the correct name and the symbol is UNO. Okay. UNO. So UNO is the symbol of this element. Very good. So now, see this tabular column. So here we have the atomic number from 101 to 1 till 118, and also we have the IUPAC nomenclature and the symbol. And also the IUPAC official name is given. You have to study the IUPAC official name along with the IUPAC symbol for the IUPAC official name also. Okay? Because this may be asked in match the following type of question in the NEET and JEE examinations. Okay. So they will give anil annium and mendelevium, anil bium, nobelium, anil trium, laurentium, but anil quadium with some other name. Instead of matching it with rutherfordium, they will match it with borium or some other element. So they will ask you, they will give all these 4 sets and they will ask you to find out the incorrect match. That kind of thing, or match the following type. So anything can be asked. So you need to study both the IUPAC nomenclature and IUPAC official name for these 18 elements. Okay, clear? You are going to memorize, that's all. Nothing to understand, nothing to do with the conceptual part here. You are going to memorize the element name, that's all. Clear? Shall I go for one more question? Shall I go for one more question? Yes? So here is the question. Yeah, what would be the IUPAC name and symbol for the element with atomic number 120? You cannot tell that, ma'am, 120 is the element which hasn't been discovered. So it is out of syllabus. So we cannot provide the name for the element with atomic number 120 and all. If you are going to discover the element with atomic number 120, you will name that, right? How will you name it? And by nillium, sure. Yes, and by nillium is the name and the symbol is UBN. Very good, Manish. So two students, Manish and Roshan, both of you watching from the same ID, Jane, me, Sutia. Very good, Ravi, very good. Varalakshmi has also given me the answer for the last thing. Okay, okay, great. So now let's take one previous year question from this topic. So this is the 2022 NEET question. Okay. The IUPAC name of an element with atomic number 119 is. Which is the correct answer? Is it option A? Everybody is going for option A. Very good. Option A is the correct answer. N. For 9, we have to use N, right? Some people will get confused with non. Okay, non. For 9 in organic chemistry, we use non. Some people will get confused, but we don't have any such options which has non. So the name is NEM. Option A is the correct answer. Very good. Very good. Now the second topic of today's session is the periods and groups in periodic table. First, let's discuss about the periods. Then I will discuss about the groups. Okay. So coming to the periods, what are called as periods? Horizontal rows or vertical columns? Horizontal rows or vertical columns? So periods are called as horizontal rows, right? So there are 7 horizontal rows or 7 periods in the periodic table. Now, the filling of electrons into different orbitals. So S, P, D and F are the orbitals. The filling of electrons into this SPDF in a shell is called as electronic configuration. Okay, the filling of electrons in the orbitals is called as electronic configuration. And this periods indicates the number of the shell. So if we are saying that we have 7 periods, means we have 7 shells. If the period number is 1, then shell number 1 is present there for those elements. If I am telling the period number for a particular element is 2, then that element has 2 shells, shell number 1 and shell number 2. So if it is 3, if it is a third period, then it has shell 1, shell 2 and shell 3. Okay, so like this it goes on till 7. So now let's study each and every period. Okay, let me start with the first period. So first period means the filling of the lowest level shell, which is called as K shell. So K, L, M, K, L, M, N, these are the shells. These are the shells. Okay. This 1s, 2s are the orbitals or the subshells. Okay. So if I am saying the shell as K, then that shell has only 1s orbital. And in this 1s orbital, 2 electrons can be accommodated. And the first electron will be of hydrogen. And the second electron means 2 electrons will be there. That is for helium. So hydrogen will have 1s 1 configuration. Helium will have 1s2 configuration. So these 2 elements are present there for cation. Okay. So totally how many elements we have in the first period? 2 elements, only 2. Clear? So moving on to the second period. So in the second period, the filling of L shell takes place. L shell means I have lithium, beryllium, where the electrons are filled in 1s2 and 2s1 orbital. And for beryllium, it is 1s2, 2s2. And I have boron till neon. Boron is having 1s2, 2s2, 2p1. Carbon will have 1s2, 2s2, 2p2. So like that, it goes till neon with 1s2, 2s2, 2p6. Totally, how many elements are here in this second period? Can you give me the count? First period has 2 elements. What about the second period? How many elements does the second period has? Hey, how many elements? Yeah, 8, right? So there are 8 elements in second period. Coming to third period. In the third period, filling of M shell takes place. So it starts from sodium. For sodium, the outer electronic configuration is 3s1. So in the second period, it is ending up with 2s, right? 2, second shell, 2s to 2p1, till 2s to 2p6. If it is a third period, then it will end with 3s1. And for magnesium, it is 3s2. And from aluminium till argon, it is 3s to 3p1 till 3s to 3p6. Okay, so the shell number will be 3. The outermost shell will be 3 for the third period elements. So here in this period, how many elements are there totally? So in the first period, I had 2 elements. Second period, 8 elements. In the third period, how many elements? Same as that of second period, right? Yeah.
8.
No, no, not 18. It is 8 only. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon, right? Only 8 elements in the third period also. Coming to fourth period. Here the filling of N shell takes place. K, L, M got over. Now N. Okay. So first of all, potassium and calcium, where the s orbital will get filled with 4s1 and 4s2. Then I have the D block elements. Okay, D block. D block will take the center part of the periodic table. So it starts from scandium and ends with zinc. So in this first two element case, the filling of s orbital takes place. And here the filling of 3d orbital. Here 4s orbital and here 3d orbital filling takes place. So for scandium it is 3d1 4s2. For titanium it is 3d2 4s2. Okay, 3d2 4s2. And for vanadium it is 3d3 4s2. So like this is it goes till zinc with the 3d10 and 4s2. Okay, so these 10 elements are called as 3D transition series. 3D transition series. And also we have the filling of 4p orbital. From gallium till krypton, we have p block elements. So here the filling of 4p orbital takes place. It starts from 4s2 4p1 and it ends with 4s2 4p6. So here the filling of 4p orbital is taking place now. So these are the elements in each blocks. Now tell me the total number of elements present in fourth period. Can you calculate? So in S we have 2 elements. In D we have 10 elements. And in the P block we have 6 elements. Totally how much? Yeah, totally it is 18. So the total number of elements present in the fourth period is 18. So 2, 8, 8, 18. Now coming to fifth period. What about the fifth period? The filling of O shell takes place here. So the first two will be rubidium and strontium with the 5s1 and a 5s2 configuration. Then the next is again the filling of 4d orbital starting from yttrium and ending with cadmium with the 4d1 5s2 till 4d10 5s2, 4d transition series. And at last we have the filling of 5p orbital also. So it is starting from indium and it is ending with xenon with the configuration 5s2 5p1 till 5s2 5p6. So now here totally again we have 18 elements. So fifth period also contains 18 elements with the filling of the fifth shell. Okay. Now coming to sixth period. So in the sixth period we have these many elements. The first two is the filling of 6s orbital. Then from 57 to 71 onwards, the filling of students, am I audible? Can you able to see me now? Yeah. So from 57 till 71 onwards, the filling of 4f orbital takes place, and from 72 till 80, the filling of 5d, then from 81 to 86, the filling of 6p. So totally if you calculate, okay, you will get 32 elements in the sixth period. So this 4f orbital gets filled up from cerium to lutetium element. So 57 is the element with the name cerium, and the 71 is lutetium. Okay. So here from 57 till 71 we have 14 elements, and those 14 elements are called as lanthanoids. Those 14 elements are called as lanthanoid series. I've already given you, right, the list of lanthanoids. So here we have 2, here we have 14, here in d orbital we have 10, and coming to p orbital it is 6. So if you add up all these numbers, you will get 32. Okay, so 32 elements are present in sixth period. Then coming to seventh period, again I have these many elements. So the first two is the filling of 7s orbital. Then from 89 to 103, it is the filling of 5f orbital. Then from 104 to 112 is the filling of 6d orbital. Then from 113 to 118 is the filling of 7p orbital. Okay. So here in the seventh period, many elements are man-made radioactive elements. Okay. They are not present in the atmosphere. They are man-made elements. And coming to orbital, the elements with the atomic number 89 till 103, the 89 atomic number is given to the element actinium, and 103 is called as lawrencium. Okay, with the symbol Lr. So these 14 elements are called as actinoid series. These 14 elements are called as actinoid series, and here also we have totally 32 elements. Okay, so these are the informations about the period. So the 7 periods are there. In first period we have 2 elements. In the second period 8, third period 8, fourth period 18, fifth period also 18, and 32, 32. Okay. So these are the elements numbers. Now coming to the group information. Elements in the same group. Group means the vertical column, right? Elements in the same group has similar configuration and thus similar properties. So if two elements or a set of elements are having the same configuration, then its properties will also be same. The physical property and the chemical property will also be same. So suppose if I take group number 1, this is the these are the group number 1 elements. Okay, the first vertical column elements. So the atomic number for lithium is 3, and for sodium it is 11, for potassium it is 19, so etc. So this is the atomic number, and the symbol is also given. Electronic configuration, if you see, for lithium it is 1s2, 2s1, or helium. Helium is the nearest noble gas configuration, whose electronic configuration is 1s2. So instead of writing this 1s2, I can write helium. In the same way, for sodium, I can write as 1s2, 2s2, 2p6. Instead of writing this entire thing, I can write neon, because the neon configuration is 1s2, 2s2, 2p6 with the 3s1. And the same way for potassium, it is argon 4s1. For rubidium, it is krypton 5s1. For cesium, it is xenon 6s1. For francium, it is radon 7s1. So in all these cases, if you observe, the outer electronic configuration is 2s1, 3s1, 4s1, 5s1, 6s1, and 7s1. So generally, I can call this as ns1. So the group 1 elements are having the outer electronic configuration as ns1. So since the outer electronic configuration is similar for all these elements in a group, they can behave in a similar manner. Their physical property and chemical property will be same. Okay. So this is about the group. Then coming to the blocks. We have 4 blocks in the periodic table. We have 4 blocks in the periodic table. Okay. S, P, D and F. The first 2 groups in the periodic table are called as S block elements. Okay. Then from group 13 till 18, you can see, right, from group 13 till 18, we have 6 groups, and those 6 groups are called as P block elements. Okay. Those 6 groups elements are called as P block element. Hello, Ravi, am I visible now? Yes. Okay. Listen. So we have 6 groups, 13 till 18, which are called as P block elements, but there is one exception, which is helium. Helium is not a P block element, but it is kept under the P block. Okay. Why it is not called as a P block element? The last electron does not enter into the p orbital for helium. Okay, the last electron does not enter into p orbital because we don't have p orbital at all, right? For helium, the 1s2 is the configuration for helium. We don't have p orbital for helium, but it resembles the noble gas, the neon, argon. So its behavior is similar to the other noble gases. So that's why we have kept here. Okay, but the helium is an exception. It is not a P block element. Got it? Then we have D block. We have D block and the group number starts from 3 till 12. Okay, from 3 to 12 we have D block elements and hydrogen position is the center only, center of the periodic table because it resembles both group 1 as well as group 17. So it is located at the center of the periodic table. And coming to the last group, which is called as, last block, which is called as F block, the lanthanoids and actinoids. The lanthanoids and actinoids elements are called as F block elements. Okay. So hydrogen position is the center. So this is all about the blocks S, P, D and F. Now let's discuss each and every block separately. So let me take the S block elements. As I have already told you, S block elements occupies the group number 1 and group number 2. Group number 1 elements are called as alkali metals and the outer electronic configuration for alkali metal is Ns1. This also I have discussed. And the one electron which is present in that Ns orbital, those elements will lose those one electron to form +1 ion. Okay, +1 means unipositive. Like in case of lithium, lithium will lose that one electron and it will exist as lithium plus. In case of sodium, sodium plus. Potassium, potassium plus. So all these elements will exist in their +1 form. Okay. And coming to group 2 elements are otherwise called as alkaline earth metals with electronic configuration Ns2. So since they have 2 electrons in their outermost shell, they can lose those 2 electrons and they can exist as a dipositive ion, +2. If I take beryllium, beryllium stable configuration is beryllium 2 plus. And coming to magnesium, it is magnesium 2 plus. Calcium, calcium 2 plus. Okay. So they will not be stable in beryllium plus or magnesium plus form. They will be stable in their di positive ionic form only. Okay. So group 1 elements are called as alkali metals and group 2 elements are called as alkaline earth metals. And the electronic configuration also I have given. Got it? Clear up to this? Shall I go for the next? One more thing I want to discuss about S block, and that is about the first member of these two groups. So the lithium and beryllium are the first member of these two groups, right? So except these two members, every element in the groups form ionic compound. Okay, like if I take sodium, sodium will form NaCl. Lithium will form LiCl. But lithium chloride, LiCl is covalent compound and sodium chloride is an ionic compound. And potassium also will form compound, KCl. Potassium chloride is also ionic in nature only. All others will form ionic compounds, but only the first member will form the covalent compound. Okay, so you know what is meant by covalent and ionic, right? Covalent means which is formed by the sharing of electrons, and ionic means which is formed by the transfer of electrons. Okay, likewise in the same way, beryllium also. Beryllium will form chlorides of type BeCl2, whereas other elements will form, like if I take magnesium, it is MgCl2, calcium CaCl2, strontium SrCl2, barium BaCl2, like this. But only the beryllium chloride is covalent in nature, but all others are ionic in nature. Okay, so this is a speciality of the first member. So the reasons of this for this will be discussed later in this section, in this lesson. Okay, so except the first member, all others will form ionic compounds. And the metallic character increases on moving down the group. If the metallic character increases, can you tell me which one is most metallic in nature? In the first group, is it lithium or strontium and cesium? Which is more metallic? Lithium is more metallic or cesium and strontium is more metallic? The cesium and strontium, right? The metallic character increases on moving down the group. And coming to the reactivity, very good. Coming to the reactivity, it also increases on moving down the group. If I compare beryllium and radium or lithium and strontium, these elements are highly reactive in nature. If they are very highly reactive, they cannot found in the pure form, right? In the nature, they are never found in the pure form in the nature, because once if they find some other element in the atmosphere, they will go and react with that element and they will be converted into some other compound. So you cannot find radium or barium in the pure form. Pure form means barium form. Barium will react with oxygen present in the atmosphere and it will be having the formula BaO. We can able to find the barium in barium oxide form only, not in the pure state of barium. Okay, because of its highest reactivity, it is existing like this. So this is all about the S block. What are the points? Group 1 is called as alkali metal, group 2 is called as alkaline earth metal. And the general electronic configuration is NS1 for group 1 and NS2 for group 2. And the first member is different from the other, means the first will form covalent compound, the other will form ionic compound. Then the fourth point is metallic nature increases. Fifth point is reactivity increases. Got it? So this is all about the S block elements. Then from P block elements onwards, we will discuss in the next class. Okay? Any doubt from today's session for anyone? Everything clear? Everything clear for all of you? Yes. So just go through the introductory part, which is the modern periodic table part, and groups, periods, informations, and the S block informations in your book. Okay. So in the next class, we will start with the P block. So thank you so much for listening, students. So meet you all in the next session. Take care. Bye-bye.